Hi guys, so this is a video tutorial for this problem that was posted by Richard S. on June 10th, 2021. So it's asking us to calculate the molecular formulas and it gives us this information. So first we need to understand how to calculate an empirical formula, and then from that once we have the empirical formula, we can get the molecular formula. So this is a step-by-step introduction on how to do it. So first we want to pay attention to the relevant information. So we're going to highlight the percentages and the identities of which elements, its molecular mass, which will be used later, and then we want to calculate the molecular formula for this compound. So first, we want to list out all the elements and their percentages. So let's rewrite all of these guys down here. So carbon is 54.5%, hydrogen is 9.1%, oxygen is 36.4%. And the sum of all these guys should equal 100 because these are all the numbers that were given to us. So now, assume a total mass of 100 grams. You can do any power of 10 really. You can do 10, you can do 100, you can do 1,000, but 100 is the easiest to work with because that's typically what percentages are based off of. So let's assume total mass equals 100 grams. So from that, we can convert these guys directly into masses in grams. So for this one, let's make a little room. This will turn into 54.5 grams, 9.1 grams, 36.4 grams. Okay, so we just did number 2. Number 3, based on that assumption, list out the grams for each element from their percentage, which is what we just did. We convert the same numerical value, we just change the units. And then 4, determine the number of moles of each. So we want to convert this into moles now. Same thing here, moles and moles. So let's do that. And I think we can erase this part now. So to convert these guys into moles, let's also give ourselves a little more room. We need to multiply by the molar mass. So for carbon, the molar mass equals 12.01 grams per mole. For hydrogen, it's 1.008 grams per mole. And then for oxygen, it's 16 grams per mole. So now let's put these guys in. Since we want to cancel out the grams and be left with the moles, we will put the 12.01 grams in the denominator and the moles in the numerator. So 1 mole equals 12.01 grams, right? So for every 1 mole of carbon, it weighs 12.01 grams. And then we calculate that. So same thing here. 1 mole of hydrogen equals 1.008 grams. And then lastly for oxygen, 1 mole, 16 grams. So now let's calculate these things. 54.5 divided by 12.01, that equals 4.538. Okay, we're estimating. 9.1 divided by 1.008, that's just 9.028. And then for oxygen, 36.4 divided by 16, that's 2.275. Okay, so we just did number 4. Step 5, determine the number ratio of moles. Then divide all the numbers by that smallest number. So what we're going to do is we're going to write out this CHO. And these numbers will be written as subscripts on this crude equation that we're working with right now. So moles of carbon is 4.538. Moles of hydrogen 9.028 moles of oxygen, 2.275. Okay, so now all these guys are subscripts. Then it wants us to divide all the numbers by the smallest number. So of these three numbers, we see that 2.275 is the smallest number. So we're going to divide every one of these numbers by that. So divided by 2.275, divided by 2.275. Now we have this. So if we plug in 4.538 divided by 2.275, this turns into C sub 1.99 ... because we don't really care about that last part. We're just estimating here. So 9.028 divided by 2.275. This is 3.97. And then oxygen, this number divided by the same number is just going to be 1. So now we want to round these guys to the closest number, and it should be fairly obvious when you're doing these types of problems. So for this one, right, we'll round it up to C2H. This is 3.97, so we'll round it up to 4, and then O1. But because it's a 1, we don't write it there. So now so this is what's called the empirical formula. So let's write that down here. Did I spell that right? Yep. So this is the empirical formula. Now we need to convert this into the molecular formula. Okay. Now for these steps in the molecular formula. Once we determine the empirical formula, which we just did, we want to divide the molecular weight of the sample given, which is right here, by the empirical formula weight, which we just calculated. So the weight of this, right, it's called the formula weight. So let's do carbons, hydrogens, then oxygens. So carbons, you have 2 of them, each of them are worth 12.01, plus hydrogens, you have 4 of them, each of them are worth 1.008, plus oxygen, you have 1 of them, each one is worth 16 units. So 2 times 12.01, this is 24.02, plus 4 times 1.008, that equals 4.032, plus 16. So you sum these guys together, and this 44.052 grams per mole is our formula weight. Okay, so that's what we just calculated. So now we have the empirical formula weight. We need to divide the molecular weight of the sample, which again is given by the empirical formula weight. So this is 88 grams. So 88 divided by 44.052. And this is about 1.998 ... So that's about 2. Okay. So this 2 right here is the coefficient by which we're going to multiply this empirical formula by. So we see here, multiply that whole number multiple to each of the coefficients in that empirical formula. So 2 times C2H4O, and this is our empirical formula. Now we're getting our molecular formula, and that's going to be C4H8O2. Now, in case you forgot, this is just a little review. Empirical formula is the formula of the smallest common multiples of everything here. So we see here these can no longer be divided by one another. And then the molecular formula tends to be a multiple of the empirical formula. So usually in molecular formulas, like for example glucose, it is some type of organic, like carbon, hydrogen, and oxygen containing molecule, but it won't always be in the empirical form. However, if you're talking about ionic compounds, for example, NaCl, because of the repeating structure of these ionic compounds called the crystal lattice, it's really hard to identify a discrete molecule. So that's why it could be Na like 1000, Cl 1000, but it's really hard to be able to tell individuals apart. So that's why we just go with the smallest multiple of each, or the smallest whole number ratio of each. Okay. Um, so yeah, if you guys enjoyed this video, please let me know. And I'm also on Wyzant, so if this is where you found me from, please check out my profile if you need tutoring help in the future. Thank you.